Distinguish between kinetics and thermodynamics. The question asks why the reaction occurs at a significant rate only at elevated temperatures, above 200 degrees Celsius. Rate is a kinetic property that describes how fast a chemical reaction occurs. In contrast, properties like enthalpy, delta H degrees, entropy, delta S degrees, and free energy, delta G degrees, are thermodynamic properties that describe the net energy changes and spontaneity of a process. This means the correct explanation must be rooted in kinetics rather than thermodynamics. Apply collision theory to explain reaction rates. According to collision theory, for a reaction to occur, reactant particles must collide with sufficient energy to break existing chemical bonds and form new ones. The minimum kinetic energy that colliding molecules must possess for a reaction to occur is called the activation energy, EA. Analyze the kinetic effect of increasing temperature. At lower temperatures, the average kinetic energy of the molecules is low. Only an extremely small fraction of reactant collisions have enough energy to equal or exceed the activation energy. When the temperature is increased, the average kinetic energy and speed of the reactant particles increase, shifting their Maxwell-Boltzmann distribution to higher speeds. This significantly increases both the frequency of collisions and, more importantly, the fraction of collisions that possess energy greater than or equal to the activation energy. Conclude why the high temperature is necessary. Because this solid gas storage reaction requires a high temperature, greater than 200 degrees Celsius, to occur at a useful, significant rate. The barrier preventing reactant molecules from transforming into product molecules must be high. This indicates that the reaction has a high activation energy under standard conditions. This directly corresponds to option C. The correct answer is option C. The reaction has a high activation energy.